So in this video, we're going to take a look at the general method of how to factorize a quadratic. And this works regardless of the quadratic, if it can be factorized. And the important difference between this and the previous videos is there is, look, a number there in front of the x squared now. Okay, so if we see this, we're going to follow this technique. Now, there's many ways to do this. I am going to teach you an algorithm that you just need to remember and follow to get the answer. Okay, so step number one. All we're going to do is we're going to take the number that is the coefficient of x squared, so 2, and the constant number, which is the one on the end, which in this case is minus 3, and multiply them together. So we're going to take that, we're going to do 2 times a minus 3, and that is going to give us a minus 6. And I'm going to now refer to that as the target number, right? I'll write Tn for target number, which is minus 6. I call this the target number method. Okay. Step number 2, we are going to take that target number and think about it. We're going to also think about the number that is in front of the x. Now, in this example, there's no number there, but really it's minus 1x, right? So we're going to think about minus 1. And we're looking to take our target number, which is minus 6, and to think about two numbers that multiply to make minus 6, but add to make that middle coefficient the minus 1. So that's going to be minus 3 and a positive 2. Okay, so that is step number 2. Step number 3. We are now going to rewrite our original quadratic, but we're going to split apart that middle term into those two component pieces. So what I mean by that is we're going to keep the 2x squared the same, but that middle term, we're going to write it as minus 3x and a positive 2x. We'll keep that minus 3 the same. So I've taken those numbers and I've written them, look, here, it's still the same thing, okay? Minus 3 and a plus 2 is still a minus 1. We haven't altered the quadratic. Okay, step number 4. We're now going to factorize in a linear fashion what you've been doing in previous years, two different halves of this particular quadratic. So we're going to take that part and we're going to take that part, and we are going to factorize them. So if I look at the left-hand side, I can take out a factor of x. X bracket 2x minus 3. Now, on the right-hand side, okay, the 2x minus 3, there doesn't appear to be anything that I can really take out. So if that's the case, well, I'm going to take out a 1 and just rewrite it as 2x minus 3 multiplied by 1. That keeps it exactly the same. Now, I'm trying to get a situation where I have the same bracket appearing twice. And if you follow the algorithm, that is absolutely going to work, okay? There'll be a way to do it. Sometimes you've got to think a bit carefully, but we have to do it. Right. Now then, part number 5, right? Okay, this is the final piece. So I've created a situation where I have x multiplying by 2x minus 3, and I have a 1 multiplying by 2x minus 3. So if I have x multiplying by 2x minus 3 and a 1 multiplying 2x minus 3, overall what I've got is x plus 1 multiplying 2x minus 3. We can take those pieces and we can put them into one bracket, all together multiplying 2x minus 3, and now we have managed to complete our factorization. Okay, so hopefully you understood that. Now let's have a go at some more examples. See if you can follow that algorithm. All right, so we'll start off with this one, 3x squared minus 2x minus 1. Okay, step number 1, target number is minus 3. Step number 2, we're going to think what two numbers multiply to make minus 3 and add to make minus 2. That's going to be minus 3 and a positive 1. Okay, next step, we're going to rewrite that middle term, 3x squared minus 3x plus 1x minus 1. Next step, we're going to factorize the left. Separately to that, we're going to factorize the right. When I factorize the left, I'll have 3x common to both terms, x minus 1. And then on the right-hand side, in order to get that minus 1 bracket, I'm just going to write a 1 there. Finally, if I have 3x times x minus 1 and 1 multiplying x minus 1, overall, I've got 3x plus 1 multiplying x minus 1, and we're finished. Okay, let's do another example. This one looks a little more complicated, so let's talk it out. Step number 1. Target number is 6 times 12. This is going to be 72. Step number 2. I need to think about two numbers that multiply to make 72 and add to make minus 17. Now, they're going to both have to be negative, so I don't know this off the top of my head, so let's start thinking about numbers that multiply to make 72. Well, the first one that I can think of is going to be 8 times 9, and of course 8 plus 9 is 17. We're going to be in straight away, so it's going to be minus 8 and minus 9 here. Okay, so let's rewrite this. So we're going to have 6x squared. Now I'm going to write the minus 9 first because it might make it easier for me when I'm factorizing the 6 with the 9. Okay, so we're going to write it out like that. Now we're going to factorize the left. I can take out a factor of 3x, and that will leave me with 2x and a minus 3. On the right-hand side, I'm going to take out a factor of minus 4, and that's going to leave me with a 2x and a minus 3 as well. Now I can bring them together. 3x minus 4, 2x minus 3, and I'm finished. I've factorized my quadratic. Let's do one more of these. So, step number 1, the target number, minus 24, 8 times minus 3. Step number 2, we're going to split this up. Two numbers that multiply to make minus 24 and add to make 10. Well, it's going to be 12 and minus 2. Now we're going to rewrite this with that as our middle term. So 8x squared plus 12x minus 2x minus 3. Okay. Next one we're going to do, factorize the left. We're going to have 4x bracket 2x plus 3. And then on the right-hand side, in order to keep the same bracket, I'm going to take out a factor of minus 1, giving me 2x and a plus 3. And then we're going to factorize the two pieces. We're going to have 4x minus 1, 2x plus 3. Okay, I hope that technique helps you to factorize any quadratic.